In this demo, we would like to implement remote procedure call from scratch. So basically, we would like to be able to publish a service on the server side and then invoke it in a simpler and cleaner way from the client. So let's start by creating a new project. Let's call it demo. And in here, I would like to have a new package with the same name. And for testing, because we are developing some kind of a framework, I would like to have a dedicated source folder that is going to be called test. And in here I will have the same demo package. So basically what we have to do in order to implement this would be to create a request and send the request to the server, and the server will process the request by executing the appropriate service with the requested method. Okay, so let's start by defining in the framework our objects. We need to have an, let's call it an RPC request, and this request is going to specify, okay, let me adjust the font for you to be able to see it better. Okay, so I will just enlarge the basic font to 16. It's okay. And in here, I would like to be able to say by using a JSON RPC approach, in which I will define which service I want to call, also the name of the method that I want to invoke. I will have to send the parameters to call the method, let's call it arguments, this field, and I would expect to create an instance of the service on the server side and receive a session ID, which can be used to invoke the same object later on. So let's say I would have to store here and send it to the server a session ID. Based on that, I will create constructors with these fields, okay? And because I will need to be able to deserialize this by having a constructor with no arguments, I will just declare this constructor that will have no visibility on the outside. It's called RPC request. And just for not having those warnings about the fact that I'm not calling the constructor, I will call it in here. Beside that, I would like to have getters for all the elements that were defined here. So I will just go and create getters and setters. I don't need setters, but only getters, and that should be the last member in the class. Okay, so now this is what I will send to the server. I will say call this service, from this service call this method with these arguments, and if there is a session created on the server, then reuse it. Okay, now let's go and create a class for the response, for the RPC response. So what the server should deliver as a result. First of all, I will need to send an object which will be the actual result of executing the method remotely. In case I will have an exception, this exception should be sent to the client, but I would prefer to have this as a string, and I will create a checked exception for all the exceptions coming from the server. And beside that, if a new object is created on the server, the session ID should be sent to the client as well. So I will create getters for these fields, except for the result that, okay, I will create a getter for the result as well, but this should be deserialized according to the result type of the return type of the method. So I will only have getters as last members in the class, and in here sorry for that. In here I will just get the elements from my class. So basically that's what my service should do. This is the protocol that should be used. And what I would like to have is the ability to invoke the methods on the server side. So let's say that I will have an RPC skeleton which is gonna handle a request and create the appropriate response. This skeleton is gonna be created for a particular service type, so I'll have to specify the type of the service. That should be a class. And what I'm gonna do here, I will just store the type as a class field, and then remember the idea is that when a connection is requesting to execute a method, we'll have to create a skeleton on the server side, and then based on the instance wrapped by the skeleton, invoke the appropriate method. So what we would like to do here will be to get a constructor with no parameters from the type. So I'll just say type get declared constructor with no parameters. Let me adjust the code assistant as well, content assistant, on Java content assistant. I would like to have completion right away. Okay, this might throw no such method exception or security exception, and I will have to make the constructor accessible if it's not. So let's check if the constructor is accessible, and if it's not accessible, then I'll have to make it accessible by setting set accessible to true. In the end, I will have to let it as it was, so let it false if it was false. And in between, I'd like to instantiate the object. So let's say I'll have an instance in my class that will be created by calling new instance on the constructor with no arguments. This might throw another exceptions, but first let's create the object. Okay, sorry for that. And of course the appropriate exceptions. So I have a bunch of exceptions in here. Nevertheless, I will wrap these exceptions in the end, so I'll have only a checked exception, but not the one that's defined for by reflection, but I will have my checked exception. Okay, except for that, I also need to create a session ID. So let's say that I will have to have a session ID in here, and I will use an uniform unique identifier generator to generate a random UUID and then get the toString of it. So this field should be created inside my class. Okay, so that's what a skeleton should do first. But then another option would be to have created already an instance, so I might need to have an RPC skeleton constructor based on an object instance that was passed as a singleton for the channel, for the service in the channel. So in this case, I'll have to keep the reference inside my class, and of course create a getter type. This type would be instance.getClass. But I won't create a session this time because I'm not gonna create a new skeleton each time. So based on this object, I will only have one skeleton for all the client requests. I will expose my session outside, so declare a getter for it. And the most common scenario would be that this skeleton will provide a method to process a request. So let's say that I have a public void method called process actually, and this will get an RPC request as a parameter, and of course an RPC response as the second parameter. So those should be the response. What I would like to do here, suppose that I got a request and I have to deliver the response. That means that I have to select the method of the service based on the name from the request, call the method with the appropriate parameters that I got from my request, and then collect the result or either the fault if I got an exception. So what I will do here would be to try to execute my code, and in case I will have a generic exception, okay, catch, sorry for that, catch exception, let's call it E. I will, in case of an exception, I will set the fault of my response. By the way, let's check that I have the correct setter for that. I don't have setters, so I'll have to create it, because I will actually set the values of my response one at a time. So let's go to the source. I deleted the getters, I don't know why, but I would like to have them in the same place, and therefore I decided to generate them again. Okay, so I'll just set the fault to be the exception get localized message. That's one step. Second one would be, since I have a skeleton created, I can set the session ID of the response to be the value of the session field in my skeleton. Second step would be to get the method that needs to be invoked. The problem is that I only have the name of the method, but I don't have any information about parameters. So I will create an utility method called getMethod, and this is going to return, based on the name of the method from the request, it's going to return a Java lang reflect method. So I have to create this utility method. Basically, I will iterate through all the methods that are in my class, and because my type is gonna be a service, I will go through all the methods that are declared in my service. Eventually, or optionally, I can go and check the methods that are inherited by my service. So for this I will only get the declared methods of my type, and of course I will iterate through all the methods that I have. So I will go each one declared method, let's call it declared methods. I will go with a declared method over my declared methods, and if the declared method dot get name equals with method get name, I will just method it's already a string, so with method I will return the declared method. Otherwise this should return none. So basically I don't have support for overriding the methods. I only get the first method by the name. But that's one limitation. I can live with it, no problem with that. Okay, let's move forward and see what we have to do. In order to invoke the method, we'll have to go through each of the parameters that we got from the request. The problem is that the parameters are already serialized as JSON strings. I'm gonna use JSON for that, but I don't need them as strings, so I have to deserialize them according to the type of the parameters in my method. So let's say that I have a class array with parameters, and I will just say method get parameter types, and those should be my parameters. I will let it simply just call it parameters, not parameter types. But I would like to deserialize my arguments according to those types. So those would be my arguments, and in the beginning I would say that my arguments should have the value the values that were passed by the sender, the caller. And now I will go over my parameters. Let's say arguments. They're supposed to have the same size. Otherwise, I'll get an exception. And deserialize them according to the type of the parameter in the method. But as I said, I'm going to use a JSON formatter, and for that I would like to copy an already implemented serializer, but that was for the we're gonna see this demo during the formatter topic. Now I just renamed this. I also defined a checked exception in here for the formatter that I will have to copy it as well. So let's check and change the package of this as well. And in here I have another exception because I'm using an utility class that's gonna get the value of a primitive type. So let's copy this here as well, change the name of the package, and then make sure that it's imported correctly. Okay, so now I can continue with my skeleton in order to deserialize the parameters. So basically I'll have to see if the parameters of I, it's an array, because if it's an array, then I will have to deserialize the array based on the component type. So arguments of I should be deserialized with the JSON formatter with the deserialize method. The value is already a string, but it is declared object, so I'll have to make it being a string, and I'll specify the component type as being the type of the elements. Otherwise, I will just set the value of the arguments of the current argument by deserializing from arguments of I dot to string, and the type should be parameters of I. Okay, so in this way I make sure that after deserializing the request, all the parameters are deserialized according to the type of the parameter in the method. Now I will get the result, and the result will be obtained by invoking the method. So I'll call the method invoke. The instance should be this instance, and the arguments that I've already deserialized. And after the result was obtained, then I'm just setting it in the response. If I get an exception, I will serialize the fault. So basically that's my skeleton, a simple class to wrap over an instance of a service and then invoke the requested method to generate the response. This skeleton is going to be used by a service inside my host, inside my server. So let's create an RPC service. Okay, and the service is going to be published on a dedicated context, but the context will be managed by the channel, so I don't have to worry about this. However, my RPC service is gonna create an instance of a particular type. That's the type of the service. Okay, so what I do here is to store the type inside my class, and then I will need to create a map of skeletons indexed by the session ID. So I will have a skeletons map, and I just have to instantiate this, let's say, by as being a hash map. Okay, so my service will actually be used by the channel to process a request, and the service will decide if there is a skeleton based on the session ID from the request, and then dispatch the processing to that skeleton. Otherwise, it will have to create a skeleton and then do the same. So I'll need a process method in here as well, which will get an RPC request. Sorry for that. Let's call it request. That will create an RPC response called response. So my method will try to execute, and in case an exception occurs, this exception should be set as being the fault of the response, the e.getLocalizedException. So first, I'm getting the session from the request. So session should be get session. Okay, get session. And then I will get an RPC skeleton for that session. Let's call it skeleton. In case the session is not null, and I already have in my skeletons map a key for that session value, then I will just get from my skeletons map, I will get the object based on the session as being the key. Otherwise, I will create a new one of my service type. And of course, as you saw, when I'm creating the skeleton, then the skeleton will generate the session ID, and the session ID will be sent to the client. But I forgot something which is important, that when I'm creating a new skeleton, I have to store it in my skeleton list. So that's obviously, I'm not doing this here correctly. So let's do it properly. So I would have to check first, and I have to check and see if the session is not null, and I already have a skeleton for that. That's one option. So in this case, I will have to create. So let me refactor this. If it's null, or this doesn't contain the session. Okay, so if it doesn't contain the session, then I will just create a new session, a new skeleton, an RPC skeleton. Okay, that should be the new skeleton, and of course I will index the skeleton in my map. Skeletons put, the key should be skeleton.getSession and the value that was already created. And now I can get my skeleton from the map and call it to process the request to get the response. So this is actually what has to be done here. Otherwise, I will end up creating skeletons for each request because I was not putting them in the map. So basically, that's the service, a simple class to create objects of a particular type. Okay. Yeah, so other option when I publish a service would be to deliver a singleton, and in this case I will have to have in my class a private. I will have either um, a session, a map of skeletons, or only one instance. Okay, and for that I can have a private skeleton, RPC skeleton. Let's call it skeleton. This will be a single instance, and I can create a service based on that, based on an instance of the service that should be a singleton. In this case, I will have to create a new skeleton with that instance. Okay, and if I have this one already created, then I don't care about the session. Okay, so let me check if my skeleton is not null, then I will process the request with this. Otherwise I will process it with this one. Okay, and I can write it like this. I have an RPC skeleton, let's call it skeleton. Okay, initially it will be null, and if this dot skeleton is not null, then my skeleton should be this dot skeleton. Okay, just a second, this dot skeleton. Otherwise I will create a new skeleton, and this new skeleton should be indexed, and in the end, in here, I will say that skeleton should be skeletons get based on the session, which is not okay, sorry. So just let me write it correctly. If I have the session and the session is null or contains this one, then I will just create a new skeleton, store the session as being the new skeleton dot get session. Okay, and for this session I will index the skeleton so that now I can get the correct instance by calling this. And since on either branches I was getting the skeleton reference, now I can use it to process the instance. So what I'm doing here is basically to make it available also as a singleton. Okay, so now I can, by having this constructor, I can pass a reference of the single instance of the service, and based on that I can store in a field in my class, I can store that reference. Okay, so now this can work also in a singleton manner, except that I'm dispatching each time. If this supposed to be used as a singleton, then I will call the only singleton that I have. Otherwise I will check if I have an object for the session ID. If the session is null or I don't have the skeleton created, I will create it. I will store the session, put in the map for that session ID, get the skeleton by the session ID, and in the end I will process the request with that. Okay, now that we've done that, we'll have to create an RPC server that's going to be the channel which will handle the request. So let's create a new class, call it RPC server. I would call it server, and I will have only one channel that's able to publish services. The server would have to listen on a particular port, and it will have, of course, a server socket to do that. So let's call it socket, simple socket. It will also have a map of services, and each service will be published on a dedicated context. So I'll have a map of services. Those will be my services. When I'm creating the RPC server, I will have to pass a port number for that, and it will get the network interface to listen on. This will store the port, and it will also create the map as being a hash map of services. Okay, and now that's the RPC server, not RPC service. Sorry for that. Okay, I'd like to have the ability to publish services. So I'll have a method here that's publishing a service. Let's call it publish, which will publish based on the name of the service that will become the context of the service. Will publish a class which has to be instantiated each time we want to invoke a service. So in order to do that, if the service is not null, okay, and the type is not null, otherwise I won't be able to invoke the service. And why not? I don't like to republish a service. First, unpublish it. So if the services doesn't contain a key with this name, then only then I will put my service in the map based on the name, and in here I will create an RPC service with the type. Okay, so I said that I can publish a service also based on an instance of the service. So if I have an object here that's the instance of the service, then I should be able, if my instance is not null and so on, I should be able to publish a service based on that instance. So in here I will be able to have singleton publishing as well. So I don't care about if I have the type or the instance in order to invoke the service. I'll have to create an unpublished method as well, unpublish, so I can, of course, unpublish a service. I will unpublish a service based on its name, which is the context, and only if the service name is not null and my service map contains a key for that, then I will just say services remove of the key name service. That's easy. Okay, so I've created this channel called RPC server in order to start it and listening for requests and then process the requests. So I'll have here a start void method which will start listening. What we'll do first, we'll stop the listening if it was already listening, and this will be also a public method that I need to call when I'd like to stop the server. And then I will create a thread over this and start it. So I have to implement runnable, okay, and of course I have to implement the run void method. When I'm stopping the server, I'm trying to see if the socket was instantiating, and if it is not null and is not closed, then I will just close it. So I will close the socket, which might throw an IO exception. That leads to the fact that my start method should throw an IO exception as well. Okay, now let's also override the finalize method, because I would expect to call the stop method if no one does it before, at least when this object is finalized by the VM, that should be the virtual machine, the Java virtual machine, that should be also called. Okay, so far so good. Now, when I'm running the server, what I would like to do is to create my socket. So my socket should be a new server socket that should listen on this port. This might throw an IO exception as well, so I'll just round it to try catch because I'm in a method that cannot throw the exceptions as far as it was defined. This exception, I'm not gonna give details about it, but normally I should treat this as well. So until the socket is closed, so while it's not closed, I will call a method to process the socket accepted by my server socket. So this should be a method that I have to create. And of course, in order not to overheat the processor, not to use too much of a processor time, I will just interrupt it for 200 milliseconds, which might throw an interrupted exception as well. So let's go to my socket and do it properly. What I'm supposed to do in here, what's going to happen here after I accepted a socket? First of all, I will need to do some code that might throw an exception, but remember what problem I have. So I have a server which is running on a different thread than the one that's created the instance and called the start method to open the socket and do the listening. So now I'm able to accept connections in parallel with the main thread. But in order for my server to be concurrent, I would have to create a new thread each time I accept a new TCP connection. So I'm not able to execute in the same thread. So basically, in here, I will create a runnable. Let's do it as an inner class implementation, enclosed method. And this, with my runnable, I would say what's supposed to run. But then, this should run on a thread. So I will just create a new thread based on this runnable and start the thread to process the request. From the server perspective, the client might send multiple requests on the same connection, and we shouldn't care about closing it. I will let the client to do it. So in here, I only have to process as far as the socket is not closed, and I will let the client decide when to close it. Normally, the client should not reuse this connection except if it has to be notified by this connection, but otherwise the connection should be closed after each invocation. So in here, I will try to execute some code that might throw exception, and if I got an exception, then for this demo purposes, I won't do anything with it. Normally I should log it. Okay, so what I'd like to do here, I'm at the step of being able to read and write over the socket. I will just use a buffered reader because I like to read each line at a time. So I'll create a new buffered reader based on an input stream reader, which should be based on a socket that was accepted by the server .get input stream. Socket get input stream. It's calling it accept, but we know that's a socket. Get input stream. So basically, this is the decorator pattern that I'm using in order to get the input stream, being able to read out of it, and being able to read each line at the time with physical delimiter. And I would like to use a print writer, let's call it writer, in order to output the result. And of course, this should be created on top of the socket get output stream. Those might throw IO exception, but I'm catching exception generally. And now, while my socket is not closed, I'll try to read out of it and get the data from the client with the reader read line. Okay, and if the data is null, I am not able to read anymore, or data is empty, then I will just break it. It means that the client stopped. I don't have to wait for an exception. Otherwise, I have to deserialize the request. So I'll have a request here. I'll use the same JSON formatter in order to deserialize from the data an RPC request.class. Then I'll have to create an RPC response. An RPC response, let's call it response, should be a new RPC response. And now I'll have to see what's the service that needs to be called by the request. Get service. Okay. If I have the service, so if my service map, the services, contains a key with this name, then I will simply get the appropriate RPC service for that service name and call it to process the request and response. Okay. Otherwise, this means that I don't have the service. I will just output a fault with response set fault, and I might say something like service unavailable, because I'm not able to find a service with that name. In the end, after generating the response, I will use the writer to output the response as a line. And what I am outputting would be, let's serialize the JSON serializer, JSON formatter, sorry, serialize the response. Okay, and in the end I will write this data. So actually what I'm doing here would be to serialize the result. Okay, and then after serializing it, I will flush the writer just to make sure that all the data is sent to the client, and do the same thread sleep for 200 milliseconds, not to stress too much the processor, not to consume too much processor time. Of course, I said or data is null, but I wrote end. So if data is null or it's empty, then I should break. Okay, that's my server. Quite simple. Just listening on a channel, accepting connections, and processing the request from that connection. Now let's create the support on the client side. The client should be able to have an RPC proxy that will actually handle invocations remotely. So I'll create a new class here. Let's call it RPC proxy. Proxy should also have a contract and deliver a method of that type. Okay. So my proxy, what I would like to have here, the approach would be quite simple. I would like to be able to create an instance of this proxy to call the service remotely by having a static method to do that. So I'll have a static method that will create implementation of type T, and it will get a type, and one option would be to get a string endpoint where the service should be called. And what I would like to have here will be the ability to use either a string or a URI. So I'll just return the result of calling the create method with this type, but with URI, okay, dot create based on this endpoint. And now I have to create this sorry, I have to create this method as well. That is not able to do that, so I'll just copy it. But this time this will be an URI, and I will have to implement this method. So what I'm doing when I create a proxy, that's quite simple. First of all, I will have to create an instance of RPC proxy of type T. This will be my proxy. So I will create my proxy, passing the endpoint as parameter. Okay. That's now constructed like this one. I have to create it, but I don't like to allow others to create my proxies, to create a proxy. So I will just say this should be private. Okay, and then I will create an instance to handle the requests. So I'll define here an object that should be an instance, and I will say proxy.instance, and in order to intercept the methods I will use the reflection ability to create new proxies, and I will create a proxy on the same class loader as the type. The only interface I want to implement would be the type, so the type should be an interface, okay, that should be handled by my proxy. So my proxy should be an invocation handler, okay, and in the end I will return proxy.instance. That needs to be that actually it is it has to be defined as type T. Okay, so now I have first to let my RPC proxy implement invocation handler by adding the unimplemented methods, and now I'll have to cast explicitly the result of creating a new proxy to the T type. So basically the reflection proxy is going to implement by declaring a new class all the type interfaces that I put here, and it will use this invocation handler to actually execute the methods when they are invoked. The reference that's created, it's a reference of the new type that was generated at runtime, and this instance should be used in order to handle the requests if necessary. Okay, and now let's focus on what we have to do first when we create a proxy in the constructor. Okay, so I'll need to get some information from the endpoint, because when I'm invoking the method remotely, first I will have to know to which host and on which port I should connect, and then what service to call. So I'll have to get the host from the endpoint by calling get host. I don't have a field called host, and now I have it. I'll need also the port to open the socket, so I'll get the endpoint get port, and of course define a field for the port. I will need to know what service should be invoked, and I will store it in a field called service. With endpoint I should get the path of the endpoint, and if my service, which is not defined yet, I have to do it, if my service starts with slash, which normally should do, I will have to get rid of that from the name of the service, so this should be this service dot substring of 1. And now I have the name of the service, so the URI should look like tcp dot slash slash tcp followed by the name of the host, the port, and the service. Okay, and now let's focus on invoking the service. This should be easy as pie. Okay, so when I'm invoking the method of the service, I will get the proxy, one of the parameters, the method, and of course the arguments. Okay. In here, I will um, do it quite simple. Okay, so I will have a method to invoke. I don't need the actual method but the name of it, so I will have my own invoke method here, which will say please invoke this method with these arguments and with this return type, because this is the only information I need to know. Now I'll have to implement this method. I don't care about the proxy instance that is actually dispatching the request. I only need to know the name of the method, with what argument should be invoked, and what should return. Okay? Yep. Okay. And now let's focus on actually implementing the request. So the invocation, invoke method. First, I'll have to create a socket. This would be a JavaNet socket, which is initially none. Okay. Yep. And then what I have to do here, I will try to call remotely. So I will try to execute something, like for instance connecting with the socket and so on. So in here I will have to catch a remote exception. Okay. And what I'm doing when I'm listening the socket first would be to create a socket. This should be a new server socket, a new socket, sorry, a client socket, a simple socket. And I will connect to this host on the particular port. I will create a new RPC request, and this should be my new request, which should be addressed to the service to call this method with this session. The session is not created, but I'd like to create a field named session that should be stored by the proxy to be used later on. This parameter should be called method, which is the name of the method. Then, after connecting, I would like to have a print writer. Let's call it writer, simple writer. There should be a new print writer on top of the socket get output stream. Now I'm writing with print line the result of serializing the request. So let's say that I have a string data, and this will be JSON formatter serialize request. Okay, so now I'm just outputting the data. I'm serializing the data and sending it to the server. Okay, I have to make sure that all this content is returned to the server. I will have to flush the writer. Now I have to deserialize the response, which is initially null. For that, but let's create the infrastructure first. I'll create a buffered reader, call it reader. That should be a new buffered reader on top of a new input stream reader on top of socket get input stream. And with this decorator approach, I would like to be able to deserialize the response. Okay. And what I'm doing here is to read with my reader, first to read data from the socket, one line at a time. Sorry for erasing what I wrote. So with the same data, I will call my reader to read a line. Okay, now I'll have to deserialize with JSON formatter deserialize the data as being of type response.class. Okay, and now I am able to process the response. So that's my response over here. That should be deserialized when I call my formatter to do that. Okay, and now I have to check and see if the response dot get fault it's not null, then I've got an exception. Then I will throw a new RPC exception using the response get fault. I have to create this exception, which should inherit from exception. I will have to generate a serial number for it, and of course I would like to that's all, because I will create the constructor with this one. So if I got a message to describe the exception, this should be the message. I will call super of message to initialize the exception. Okay, and now my method is catching this, but I don't have to worry, because if I got an exception, I will throw here only RPC exceptions. Sorry, I will throw here, no, I will do like this. So I will throw IO exception, okay. This one is throwing formatter exception. I'll have to catch it as well. But for this one, I will change the declaration of the method to throw this exception. And it says that the socket is never closed, which I will have to do it later on. So these are the exceptions that I have to catch. And if I got these exceptions, I will have to throw a new RPC exception. Okay, so my method will throw an RPC exception. Okay, that means that I will create a new RPC exception, and I will have to create a new constructor eventually with this signature inside my class that will call, of course, super of exception. Okay, so far so good. So I went to the point that I got the result, I got the response. I was checking if the response contains an exception, and if so, I was supposed to throw an exception. Otherwise, let's get stored in the session field of the response of the RPC proxy. From my response, I will get the session value. So each time I will change the session. First time I have a null session, the server will create one for me, and it will send me the value, and I will have to store it to be used later on. As you can see, when I'm doing the request in here, I use the value of the session. Okay. Next, let's get the result from the response. Response.getResult. The problem is that the result is serialized as string, because when I deserialized it, it only knows from the RPC response that the type of the result should be object, and it's not able to deserialize the generic object, and it will let it as string as it was received. So what I have to do here is to check the result type. the result type, let's call it result type, it's the return type of the method, it's the type of the result. If this it's different than void.class, and if it's not, this is not equals void, I will have to deserialize the result. So I will use the JSON formatter to deserialize the result, which is a string, okay, to the return type, which is the result type. And to make sure I won't get a null pointer exception, I will cast it to a string, because I know for sure that's a string. So that's not an issue with null pointer exception. I might get a null pointer, a null result, but I don't have to go into null pointer exception. In the end, I will return the result, which makes this unreachable. Finally, I will have to make sure that my socket is closed. So I'll have to check if socket is not null, and if socket is not closed, then call socket.close. This might throw an exception as well. I will have to surround it with try catch. And this IO exception will be thrown as a new RPC exception, because when I encounter this exception while trying to close the proxy after invoking a method, this is as well an exception caused by the invocation of the method. So now I have the proxy created that's able to handle my request. There's only one problem that needs to be addressed. So basically, when I'm invoking for the first time the service, in case this is not implementing singleton invocation, then I will need to tell to the server when to destroy the object. Otherwise, I will end up having a lot of skeletons on the server side. So what I'm doing here is to define a special method. This should be sorry, should be the definition should be inside the RPC request. It matters on the protocol side. So I'll create a public static and final string called destroy method, which will be called .destroy. So each time I'm invoking a destroy method, this will destroy the skeleton on the server. Okay, that's one part of the story. Now I should also go to the RPC proxy, and in here I should create a public method to do that. So I'll have a public method called destroy, and this will just invoke a method from RPC request called destroy method, which will be destroy. Okay. First was the name of the, not this one, the method. Okay, so this is destroy method. It was doing completion for another method, for a different one. The parameters will be an object array with no value, and the result should be void.class because I don't care about the result. This might throw an RPC exception, so I have to catch it when I call. Then on the finalize, I should call destroy as well. Okay, so I make sure that if the user don't call destroy directly, eventually in the end this might be called. But then I will have to implement this on the service level, because remember that the service is the only one that's actually handling the what's happening with the instances. Okay, so when I do that, this should be handled on the client, on the server. Okay, so let's go into the RPC service. Okay, and in the process method, before dispatching the request to a particular skeleton, if the skeleton it's not null, that means that that's a singleton instance, I'll have to process the request with this. Okay, so perhaps I should not process the request if the method name is it's destroy. So let's check the method name, and if the method name from RPC request dot destroy method equals request dot get method request dot get method, okay, then I don't have to do it. So otherwise, if this is not equal, I will get the reference to the single instance as being the skeleton. So in the end, I will have to check and see if the skeleton is not null, then I will process the request. Because it's a real request, it has to invoke a method. Otherwise, if the method is destroyed, then I won't have to do it. So perhaps I should refactor this and do it before. So this is what I'm gonna do here, and it's even way better. If the method name is destroyed eventually, I will have to return. I'm not in a while, sorry for that. So I don't have to test this in here. So basically, if the method name is destroyed, then eventually I don't have to call any method, but rather check if skeleton is null and the session is not null. So if the request get session, it's not null, and I have a skeleton for that, request dot session. So first of all, let's get the session. This would be request dot get session. Okay, request get session. Yeah, and if this is not null, let's make it cleaner. And if my skeleton contains a key for this, I don't have to worry about checking whether or not that's a singleton approach, because I won't have a key if it's a singleton approach. I won't have a skeleton for this key. And if it's so, then what I have to do is go to the skeletons map and remove this, and that's all. Okay, so this is what I have to do in order to implement on the RPC service level the ability to destroy an already created skeleton. Okay, so that's what I need to do. Okay, so far so good. More than 1 hour we discussed about it. Now let's go to the test and actually implement the service. Okay, that should be the nice part where we go to do it. We got a chance to test it. So now let's create an interface that should be our contract. Okay. And in here, let's say that we have a simple method called format, which will actually formatting based on a pattern some objects on the server side. That will be the arguments. Okay, very simple. One dot missing. Okay, now let's say that we have a service which is implementing the contract. This will be the service that will gonna implement the contract. Quite simple. And of course the service will be quite difficult to implement. It will just do a message format dot format with pattern and arguments, and it will return the string. Now what we'd like to have will be to have a server that will host the service. So now let's create a new class, call it server, which will contain a main, will be a console, and what it will do, it will create an RPC server not service. Okay, let's call it server, and this will listen on 8080 port. Now this server should start, but before that we should publish a service. Let's call it simple service, and the type will be the implementer of the service, which will be the service.class. Now we are able to start the server. As you can see, we are supporting hard publishing because we might call publish or unpublish during the running of the server while the server is running. This might throw an exception, so I'll just surround this with try catch multi-block. For now it's just a simple IO exception, and I will just output the localized message of the exception just for demo purposes. After we are starting the server, I will output a message just to see that's running. So I will just say server is listening, and I will implement an exit command to stop it. Okay. For that I will have to create a buffered reader. Let's call it reader, which will be a new buffered reader on top of an input stream reader on top of system.in, which is the console in. And I will do a simple while true, reading each command at a time. So I'll read a string command by calling reader readline. If I got an exception here, I will surround this with try catch block. Of course, this will output the exception in here, but I don't want to do that. I would like to break. Okay. So the command should be defined outside, and I will read it in here. Okay. But then, if the command is null, or the command is equal to exit, ignoring cases, okay, then I will break it. So that's simple as pie. So what I'm doing here is just listening and trying to anyway, if I got an exit command, then I'll have to stop. Okay, then I will just call the server to stop. So that's basically what the server does. It's it's creating a TCP channel by creating a server socket. It's publishing the service on the server and it's starting it. That's all. Okay. Now I have to create my client. So I'll create a new class called client that should contain main as well. So my client will do a simple job. First, it will define a service that implements the contract, and it will use the RPC proxy of type. This is a generic method, so I don't bother to put the type in. I would like to invoke methods from this interface, and the endpoint should be TCP localhost local host. The port where I published the service is 8080, and of course the name of the service that I gave it. And then I will just get a message formatted by this by calling service format with the pattern hello from server exclamation mark. Come on, exclamation mark can be as a parameter as well. So the argument would be, as expected, hello from server and of course exclamation mark. And in the end, I will just output the message. Okay, now let's run the server first. Cross your fingers, and it is listening. Now run the client. Okay, and it says no. Come on, we were trying so hard to do that. Let's check what the problem is. So actually, let's try to see what's happening on the server when we are deserializing the request. So we are getting the data, but we forgot to send the requesters parameter in here. So that's one of the problem. Let's try to see it again. So now when we run the server, it's running, and now if I run the client, I will get a problem with this parameter because I think I was using a wrong index, but let me change the index so it's not 4, it should be 3. It's the 4 parameter. And now when I run it, I got the response from server. So what you see here is the ability to create, using reflection, a simple RPC server that's a channel hosting services of a specific type, or using singletons. Okay, and these channels can be invoked with a simple proxy that's able to generate implementations for a particular contract, for the interface that's the contract, and those implementations will actually do the invocation remotely to an endpoint. So now I'm able to serialize an RPC request in order to consume the service and invoke with this request the service on the server side. And the server will have, as you saw, a collection of singletons for each service, and when a method is requested to be invoked by the client, the server will then select which skeleton to invoke, and based on the session ID from the client, and then the skeleton will do the invocation, will process the request by calling the appropriate method with the parameters values that were deserialized according to the signature of the method. And after invoking the method, the result will be serialized to the sender. And also, in case a fault occurs, this will be serialized as well in the field with the same name. Basically, there are some limitations, like for instance, we are not allowing method overriding because we only get the method by the name and we have no information about the type of the parameters. We have the values of the parameters, but we don't know for sure what are the type of each parameter, which is the type of each parameter. And also the problem is that, as you can see, this needs to be correctly implemented multiple threaded, because as you can see here in the RPC server, when I'm publishing services, I don't request that's okay. I don't have to lock it because I will have only one instance accessing the services. So that's okay. But anyway, we have to make sure this scales and so on. But basically, we have the ability to invoke methods remotely.